So solving exponential equations. Let's look at those instructions first. It says use the properties of exponents to simplify each side of the equation. So what that means is if you look at like examples 3 and 4, we've got multiple bases of 3 on the left side, and then in number 4, both sides have multiple bases of 10. So we're going to use our properties of exponents to simplify those. Then we need to make sure that each side has the same base. So these first few already have the same base. And so if that's the case, then all we have to do is set the exponents equal to each other to solve. So let's look at example 1 there. 2 to the x plus 1 is equal to 2 to the 9th. The only way that equation is going to be true is if those exponents are equal to each other. So since they have the same base, both sides have a base of 2, we can simply set the exponents equal to each other. X plus 1 equal to 9, and that's a very simple equation to solve, right? Subtract 1 from both sides, x equals 8. It's an equation. There's absolutely no reason not to plug it back in. Obviously, that makes sense. If you plug 8 back in, 8 plus 1 is 9. 2 to the 9th is equal to 2 to the 9th. Okay, number 2, we have the exact same base on both sides, so we can just set the exponents equal to each other. 4n plus 5 equal to n minus 7. In this case, we've got the variable on both sides, so we want it to be on one side, so I'm going to subtract n from both sides. We've got 3n. I have a feeling the bells are going to be all messed up today. 3n plus 5 is equal to negative 7. So we need to subtract 5 from both sides. 3n is equal to negative 12. Divide by 3, so n is equal to negative 4. I would plug it back in, make sure that that works out. 4 times negative 4. I'm just worried about the exponent because they have the same base, okay? And then negative 4 minus 7, that's also negative 11. Okay? So, pretty simple, right? Okay, number 3. We have the same base on both sides, but on the left side, we have more than one of the bases. So we need to combine these two expressions right here. Okay, we need to combine these two expressions right here. So when we're multiplying like bases, what do we do with the exponents? Add. You add the exponents. So we've got k plus 2. Okay, so k plus 2 gives us 2k plus 2. Now we have a single base of 3 on both sides, so we can just set the exponents equal to each other. So 2k plus 2 equal to 5k minus 1. We have variables on both sides. We need them to be on one side, so we subtract 2k from both sides. We move the 1 by adding. 3 is equal to 3k, so that means 1 is equal to k. Again, it's an equation. No reason not to check that. So 3 to the first times 3 to the parentheses, 1 plus 2. And 3 to the parentheses, 5 times 1 minus 5. Not minus 5, minus 1. Okay, both sides give us 81. So 1 is the correct answer. Okay, I wanted to plug that in to point out the use of parentheses. Okay, when there is more than one term in the exponent, I've been encouraging you to go ahead and put parentheses around it so that you remember to type that in the calculator. Okay, let's look at number 4. 10 to the negative fourth times 10 to the ninth. We add the exponents. So I'm going to write it out. If you want to go ahead and add negative 4 and 9 to get 5, that's fine. Same thing on the right side. We add those exponents. So v plus 4 plus 2v minus 1. I'm doing this so that when you look back, you can see exactly where those numbers and variables came from. Negative 4 plus 9 is 5. V plus 2v is 3v. 4 minus 11 is negative 7. We have a single base of 10 on both sides, so we set those exponents equal to each other. This one's simple. We add 7 to both sides. 12 is equal to 3v. Divide by 3. 4 is equal to v. Check it. 10 to the negative fourth times 10 to the ninth. Is that 100,000? 10 to the parentheses, 4 plus 4 times 10 to the parentheses, 2 times 4 minus 11. Okay, left side equals right side. We are good. Okay. Now, what happens if they don't have the same base? Okay. Equations without a common base. Well, we're just going to deal with ones that even though they don't have the same base right now, they can be written so that they have the same base. Okay, so on this equation, number 5, we've got 6 to the 2x minus 10 is equal to 36. Can we write 36 so that it has a base of 6? Can we rewrite it using a power of 6? 6 squared is 36. So we're going to rewrite 36 so that it's in a form that now we've got base 6 on both sides, so we can set those exponents equal to each other. And then we add 10. 2x is equal to 12. Divide by 2. X is equal to 6. Check it. 6 raised to the parentheses 2 times 6 minus 10. It's 36. Okay. Number 6, 2 to the p minus 7 is equal to 8. Now, be careful with this. We're thinking about exponential relationships. Okay, we've got to rewrite 8 so that it has a base of 2. So 2 to the third power is 8. 2 to the third power is 8. So now we have a single base of 2 on both sides. So p minus 7 is equal to 3. Add 7 to both sides. P is equal to 10. Very easy to check this one. 10 minus 7 is 3. 2 cubed is 8. Okay, let's look at number 7. We've got 7 to the 4x plus 11, and we have 1 over 7. Now, this one is actually very easy. Remember negative exponents? Negative exponents will move things from the numerator to the denominator. So 7 to the negative first is equal to 1 over 7. 7 to the negative first is equal to 1 over 7. So now we have a base of 7 on both sides, so 4x plus 11 is equal to negative 1. Subtract 11 from both sides. 4x is equal to negative 12. Divide by 4. X is equal to negative 3. 4 times negative 3 is negative 12. Plus 11 is negative 1. 7 to the negative first is 1/7. Okay, 32 is a power of 2. 2 to the 5th is 32. So we set those exponents equal to each other. 5 is equal to 2m minus 9. Add 9 to both sides. 14 is equal to 2m. Divide by 2. So 7 is equal to m. 2 times 7 is 14. 14 minus 9 is 5. 2 to the 5th is 32. Okay, number 9. 27 to the 2x plus 6 is equal to 3 to the 2x. 27 is 3 cubed. Now, we haven't dealt with this yet. All the ones that we've rewritten haven't had an exponent already, but this one does have an exponent. So notice how I write it. I put the 3 cubed in parentheses, because 3 cubed is equal to 27, and then I keep its current exponent. So we talked about 2 of our exponent rules so far. When we multiply like bases, we add the exponents. Negative exponents move us to the denominator. Does anybody remember what we do when we raise a power to another power? We multiply. So this is going to be 3 times 2 plus 6. And we're going to have to distribute that. Okay, but we have a base of 3 on both sides. So I'm going to drop the bases and I'm going to distribute that 3. So we get 6x plus 18. Okay, make sure you multiply it by both those terms, not just the first one. And multiply both terms. And then subtract the 6x from both sides. 18 is equal to negative 4x. Divide by negative 4, so that's what, negative 9 over 2. All of our answers have been whole numbers so far, but there was nothing that said that our answers had to be whole numbers. So let's check this. 27 to the parentheses. 2 times negative 9 over 2 plus 6. 3 raised to the parentheses 2 times negative 9 over 2. Really weird looking number, but left side equals right side. And that's all we care about. Okay. We don't care what that number is as long as it's the same for both sides. Okay, let's do another one like that. Number 10. 4 to the y plus 2 is equal to 16 to the y minus 3. So 4 and 16 can both be written with a base of 4. 16 is 4 squared. So we've got y plus 2 is equal to 2 times y minus 3. So y plus 2 is equal to 2y minus 6. Subtract y from both sides. Add 6 to both sides. 8 is equal to y. Check it. That'll be 4 to the 10th. 8 plus 2. And 16 to the 8 minus 3 is 5. Okay, so same number.